So we haven't covered the voice part or speech part last time, right? Any questions? Yeah, it was a little bit difficult. I mean, this lecture was a little difficult to follow, and also, yeah, I kind of forgot, yeah, yeah, um, yeah, many of these contents in the lecture. So let's try my best. And yeah, first of all, there was a, yeah, I'm not sure where it is, where it appears, but in the speech recognition or speech processing, there is something called phoneme, like phoneme. So what's the meaning of it? Phoneme. So I think it's, yeah, I'm not sure about the exact definition of, but probably unit of sound, but maybe human sound. Okay. it's not like formal definition. It's just my own definition. And yeah, so yeah, it corresponds to, yeah, roughly each character, not in our alphabet, but in this pronunciation kind of, yeah, letters. Right? Yep. Okay. So yeah, I think this guy and also and ta and yeah, it's like that. And each of these are corresponding to phoneme, right? And then yeah, it's not like mapped one-to-one to, yeah, it's not one-to-one map to our alphabet from A to Z, right? It's kind of slightly different. And let me just turn it off. And yeah, I'm not sure about the English name, but in Korean 뭐 약간 그런 거 있죠. 뭐 찰과음 뭐 있죠? 그런 거. 여기 떨어서 나오는 게 뭐죠? 뭐 유성음, 무성음 뭐 그런 류의 뭐 많이 있잖아요. Okay, so so people define the distinct, different, like sound level alphabet, and that corresponds to the phoneme. And yeah, there is a fixed number of phonemes defined, and then each phoneme is represented as a sound signal, as a Okay, yeah. So this k is corresponding to some sound signal in this waveform over time as a time series signal, and then this a is also corresponding to some segment of this waveform. Okay, but it is not. It doesn't have a specific. It may have some variation because every person has different voice, and also it can be elongated, for example. So m can be pronunciated as a, but a also is corresponding to just a single phoneme. Okay. So basically, in this speech recognition, in this kind of waveform of these time series signal, and it's lying in this continuous time domain, and the main task in the traditional speech recognition was to segment them, and then map it or classify it into one of our phoneme. Okay, so it can be like k, k, and a, e, and things like that. Okay, but usually we make the signal as a kind of discrete time units. So we don't directly handle this continuous time domain signal, but we basically chop them with the equal lengths, right? As maybe t being 20 millisecond or 40 millisecond and so on. And then if multiple time segments are corresponding to this a, and then it is just classified into the same class or same category for multiple time series. Okay. And then usually we use a traditional machine learning model that maps each time segment of our waveform into one of these phonemes, or done by HMM or hidden Markov model, right? And then I need to troubleshoot this problem.